missed the live lecture or the Discord had the issue with the microphone, then this is a supplemental for that. Check out week 11 unit test, dependency injection, and service utilities. But pretty much you can follow the instructions and get through it pretty easily. Check out assignment 3. We're gonna have to add unit tests and DI, but it's not too difficult. And we can't finish it until next week's lecture, but you could start it. And I suggest you do. Like I said, it's not difficult, but it's time consuming. Not a lot of code, but it could hold you up. Anyway, so what you want to do, open a brand new VS Code, open a blank folder, and we'll just make a like a blank .NET MVC project, and make sure you call it MVC demo app because the rest of this will depend on or rely on the naming. And if you're when you're doing this with assignment 3, it's also going to be the same way. So you have to make sure you call all of your apps the same. I've done this hundreds of times before, just a blank app. I'm going to still run it. Change to the directory MVC demo, and then .NET run. Just to make sure it works. And there's our program. No big deal. So this is kind of backwards because next week we're going to talk about coupling and decoupling, but we need to know how to kind of do this for unit testing. It's kind of backwards, not a huge deal. But what we want to do is we want to take functions out of controllers that we could otherwise use in every controller instead of a specific one and put it into like its own file. It'll become more apparent when we're actually doing the work. So in regards to your assignment 2, you guys had the stoic where you calculated like 120 and blood pressure and all of that. Well, you had functions in your controllers. Instead of that, we'll just make some simple functions. In fact, it'll just be something like, public int add, right? And then we'll just do return a plus b. And we'll do one for multiply. This is nothing new, right? So two functions. And then in our index, we will just set a view data, and we can call it add. Call it whatever you want, but add is fine. And then we'll call our function, 3 and 4. So our view data add should equal 7. Then we'll do one for multiply, right? And it'll be 20. And then in our index, we'll display it on the screen. I'll get rid of the welcome message, and we'll do an H1. And same again. And if we refresh the page, we can see, there's our 7, there's our 20. Pretty simple. You guys have done this already, right? No big deal. But what if I wanted to use, these functions outside of our controller, right? So sometimes these are like utility classes where, maybe I wrote some Bitcoin algorithm that is amazing and I want to use it in multiple controllers. So I'd make a file like utilities file, have the algorithm in there, and then call it from each controller. But Microsoft invented this thing called dependency injection, and it's to avoid being dependent on other files in your system. Think of it like going to Walmart and buying a toaster as opposed to building the toaster in your garage. If your toaster breaks and you bought it from Walmart, you can just go buy another one, swap it out. It doesn't even matter if it's different brand, different color, it just starts working. Whereas if the toaster you build breaks, you'd have to build another toaster or repair that one. Well, we can do the same thing with code, and we can separate this code from anywhere in our system and use it. It doesn't matter what happens with it. We can change it and whatever we want, but it doesn't affect our actual controllers. Now you can really put these anywhere, but I'm going to put them in a folder called services, like this. Sometimes, again, people will call them utilities, whatever it is. And I'm going to make a new file. And since it's math related, I'm going to call it math service. Yeah, math service .cs. Right, totally blank file. And then I'm going to grab the functions from our home controller and drop them in math. But I'm also going to say I want it of our namespace MVC demo. And we also want to name it a class, right? So public class math, like so. Pretty simple so far. Now, here comes the trick. You may have noticed in your assignment we had DB context, and in your constructor, you had, your constructor name, home controller, BP, whatever, and you had effectively a parameter that was taking your context, DB context, whatever. Well, this is because your program.cs will quote unquote inject dependencies that your controllers may or may not need. Logger is a default one because we can do logging to the system, and DB context becomes default because we use that to connect to the database, and then we can use our own. So in this case, I'm going to actually include math service, and I'll call it, math service like that. And again, this is our constructor, so we're going to say I'd like to set my local variable math service, which I haven't created yet, to the one that we pass in, and then we'll make a new one. Yeah, there we go. Oh, sorry. So now, when our controller gets instantiated, we have the math service that I've included in the services folder. I hate those math and service. I can't say it properly, or I got a lisp on it. Anyway, so we have it here. This looks good. We also have to include using MVC demo.services. Sometimes the IntelliSense doesn't work, which is like a real hassle. I don't know if anyone has experienced that. I think it's a VS Code bug. So now instead of just the add, we can do, math service. Right. So that looks okay. Couple things we're missing. In our program.cs, we have to tell our entire project that we'd like to use this dependency injection. And we did this for SQL. Before we did, I don't remember the code exactly, but it was at builder.add SQLite, a connection string, so on and so forth. And that is telling our program that we'd like to use that as dependency injection. We have to do the same with, whatever utility that we want to use. So how we do it, open up program.cs, and before you instantiate app, we'll do builder.services, and it's called add transient. I don't know where they come up with these names, and we do math service. And it should look like that. We'll just say register math service in the DI dependency injection container. Also, make sure you put the using. Again, if your VS Code is working okay, you can right click on this and do quick fix. I can't do that right now, but we'll go ahead and just do using MVC demo app.services, and that should take care of it. So once you do your build, it's a good point to check it because there's a couple steps, right? We added the DI as well as the service. I had a few errors when I was building it there. You guys didn't see it, right? But I had to fix those. I did a namespace problem. I called it services as opposed to just service. If this works, you should be able to do .NET Run, refresh your page, and you'll get the same output, right? And here it is, right here, 720, which is fine. And you're like, whoa, Harry, why? I went through all that work. I get the exact same output. What's the point? Well, number one, this separates our code so that I don't have to create an add or a multiply function every time I want to use it in each controller, but it also allows us to use our code in other projects. So I could import this entire project to some other project and use these functions. I could also do it for models and, well, I guess models and services. Technically, I run the whole thing, even the views. But this is really helpful because if we want to create a person class and use it in some other project later, because you're always going to have a person class, first name, last name, age, contact, whatever. You don't have to rewrite it. That's a waste of your time. So you may as well just make it, available. It seems like it's a lot of work for not a lot of return. However, these are examples. When you work in a larger company or co-op or whatever you're going to do, you're going to see that you have thousands of lines of code, right? Not just two functions. So this is really just an example of how it works to make sure you kind of know what to do. So that's a demo of kind of decoupling your software. Next week, we're going to decouple the database stuff, but I don't want to get into that today. Our main goal here is to actually talk about unit tests. So I'm sure you've heard of unit testing or test cases, uh, possibly in system design. I know you probably talked about use cases similar to unit tests, but a unit test is really the word unit test is kind of old. And you got to think about manufacturing. So if you're manufacturing cars or if you're manufacturing widgets of some sort, and I say widgets like a gear, anything, they call it widget when you don't know what they are manufacturing. Well, if you're making 1,000 of these every 10 minutes, you can't check all 1,000 of them, but you can check one or two. So you can pull a unit off of the line, you can check it, put a micrometer, caliper, whatever, make sure it's within spec, and you know that it's a good chance that the next 1,000 will be okay. So you're literally checking a unit to see if it's all right. So the name is kind of derived from that. At least that's what I think. We can do similar in software, and when you're working with a team of people, there's a good chance that someone might modify your code, whether it's on purpose or by accident, and it can happen really easily. For example, here's my add function, and let's say I just accidentally, for whatever reason, make it a subtract sign as opposed to add. Now, this could be a big problem, right? Because we're not adding stuff. Let's say we use the add function to add tax when you're doing a transaction. Let's say this isn't an add function, or it's an add function for altitude on a airplane's autopilot. Well, I just made it a minus, and now the plane is going to go down as opposed to up. Could be a huge problem. And with thousands or hundreds of thousands of lines of code, this might be really difficult to check because I can build the software, and because subtracting is a perfectly good mathematical operation, nothing really changes. Build succeeded. I don't even know what happened, right? So how do we check this? How do we pull that widget off the line, check it to make sure everything is okay? So this is called unit testing. Microsoft has a unit test suite. It's called xUnit, and it kind of it does. I don't know if it's a lot of work for us, but it does some work for us, and it allows us to import our entire project and check certain things in that project. And the reason why I started with dependency injection and moving our functions over is because it kind of has to be set up like this in order to do the unit tests. So what we want to do, go back to terminal, and we're going to go back a directory, right? So I have a folder called unit testing. You might have it called demo, assignment lab, whatever. But what I want to do is go back one level, and you can see there's my directory MVC demo app, but I'm going to create a new project. And as you can probably guess, we're going to do .NET new, and then xUnit is Microsoft's unit test, and I'm going to call it specifically MVC demo app dot tests, right? So this that's a Y, so MVC demo app dot tests. And when we do this, you're going to see another folder show up. Do yourself a favor, open it up, and there's only one file that you really need to worry about is the unit test 1.cs. So go take a look in there. So it's almost like a console program, that runs certain functions. So if we don't have this fact attribute, when we run this unit test, it's just going to treat this test as a regular function. It won't run anything. But when you put the fact above it, it means it's going to actually run. So it's part of the suite. There's a few of these, attributes. One's called theory. We don't deal with that, but it lets you test multiple different scenarios. But I want you to concentrate on fact for now. Okay, so we need to write a new unit test, and we don't have to use this default one. In fact, I'm going to delete it, and I'm going to make a new one called, I don't even know, math um, service test, maybe. What do we call it over here in my instructions? Yeah, math service test .cs, and we're going to use the namespace MVC demo app .tests, and let's make a constructor. And we'll come back to this in a second. And I want to make a function that actually, checks if our code is right. So we do something like this. I'm going to try our add, and I'm going to say, I'll be verbose. So should return correct sum. And I want this to run when I run our test code, so we'll put it as a factor cap, I guess, right? And then what I want to do is I want to get this math service because I want to use these functions. I want to get these functions, take it from our MVC demo, and put it over here in our add should return correct sum. So that's number one. And the way we do this is we're going to add a reference to our MVC demo app .tests from our MVC demo app, the actual website. So I'm going to take all of the files that exist in here, and effectively it's the DLL files, compile them, and then drop them into the folder over here, and then start to use them. In fact, I think it actually uses it from the bin over on this side. And we do this with a command called add reference, and you have to get the folder structure right. So right now I'm in unit testing, and we have MVC demo app and MVC demo tests, right? So there's these two. And I want to make sure that I'm in our unit tests because I'm linking MVC demo app to this other project. It'd be the same thing if I was making a console application and linking it to my website. I would have two projects. What you don't want to do, and I saw in class a few students, is go into your main project MVC demo app and then run this command. It says, .NET add reference, and then whatever it is, you're going to get an error that says circular, I don't know, error or something. And it's saying circular because you've just referenced your own project inside of a project that you own. So it's like it's literally a circle. So make sure you're in this MVC demo test folder, and then you're going to type .NET add reference, and then it'll be wherever the project is. So in my case, it's one folder back. That's the dot, then folder name, and then the project. When I do this, check out the CS proj file, and you'll notice, just like if you were in Node and you had an app settings or what is it called, package.json, and you used to install a module, this is exactly the same, except for we have a local module, right? So we have our local module, MVC demo app. And now this will give us access to our services folder. In fact, it will give us access to everything, but in this case, our services is what we want. This add reference is important. You wouldn't be able to use, you know, um, the math service from our other project. So you have to do this. In fact, in my class, if you're at the lecture, I forgot to include it in the HTML or in the create how to create unit test project, which I've added now at the end. Okay, so now we have to finish off our add should return correct sum. And xUnit has a few built-in functions that will automatically output to console. You'll see in a second. It's better just to show you, but I'm basically going to make a new variable or two new variables, whatever they are, right? And I'm going to say result equals A plus B. Or I'm sorry, we're going to do result equals math services dot add AB. Now, this math services, this is where dependency injection comes into play. Because we have two different projects, I can't just instantiate math services alone. I guess I can kind of, but um, what we want to do is actually take our math service inside of our constructor and create like a global variable inside of our test so that we can use it, right? So this is why we took out the functions from our home controller and put them into this services file so that we can use it across the entire project. So what we do is we'll just do private read only math services, something like that. Then in our constructor will instantiate the object. So this should give us access. And you may have noticed, right? Like as I said before, our controllers for blood pressure or whatever they were, we had the dependency injection of DB context. This is exactly the same thing. So we can pass stuff around, or not. We can use certain code in different projects. We will also have to do the using statement at the top. If your VS Code is working, not unlike mine, you should be able to hover over one of these and just do quick fix, add using, but mine's not working for some reason. Something like this. And then finally, we have to return something. Or in fact, sorry, we don't have to return something. We actually have to output, what's going on. So there's this built-in unit test function called assert. And again, if your VS Code is where you do dot and see all the different types, one is equal, one is not equal. It doesn't matter. We're going to do equals, and we're going to say, I want to check if this result is the same as what I'm suspecting to happen. So in my case, I suspect or I expect that A plus B, which is 5 and 10, should be 15. And then I pass the result in. And in this scenario, what's going to happen when I run this code, the xUnit process is going to find our math service test. It's going to find this fact. It's going to run this code and run this function and say yay or nay regarding this. So let's give it a shot. So I have an error. I'm going to fix it. It says namespace cannot be directly contain members such as field methods or statements. I got to figure out what the error is and then correct it. Again, you can the code that I have posted. I think it it's close to being correct, but it's obviously it's not working. You're gonna have to modify slightly. Let's figure out what this problem is. Oh, I see my problem. I didn't even put this in a class, like public class math service test. It should be public. Right, the error was type or namespace could xUnit could only like uh, uh, I didn't have any of these in an actual class. It was just in the namespace, which won't work. Anyway, let's try to make this work. .NET test, and if everything goes good, well, oh shit, it didn't. Let's make sure we fix it. xUnit could not be found. What are you using? Blah blah blah. Typo should be capital X and unit. The IntelliSense super handy, right? All right, if this works. Oh my God, now it's still not working. Hold on. Oh geez, I have a typo, right? Math services, and I spent. I know you. I paused it, and that's like a 1 second thing for you, but I spent like 2 minutes looking for that. You should always read your error, right? It says, you know, the name math services, which this kind of threw me off. Give me a break, right? The S goes down to the next line. Does not exist in the current context. Line 23, which is right here. So change that now. Let's try. Come on. Let's try the test. Will it work? And it did. Always read these errors. I know it's like frustratingly difficult to read them. And even the unit tests look like errors. Green usually means good. I like to clear my screen as much as possible, and you can run the test. And once you do, take a look at it. Right? It says test summary: total 1, failed 0, succeeded 1, skipped 0, duration 0.8 seconds, build succeeded in 2.9 seconds. So the more tests we run or add, the more output we're gonna get. So maybe we'll do one for multiply. I should learn how to spell. Should be the correct sum. It's been so long. Math. Sum. Is it sum when you're multiplying? No. Sum is adding, right? The sum of the product. I guess it would be the product, right? Not the sum. Product. And we'll do the same. A, B, instead of that, we'll do multiply, which means we're expecting 50. So we'll save that. We're going to run the test. And I added, there's a dash V for verbose, and the default one tells you a little less than, I guess it's normal. And then there's a more detailed one, but we'll just use the regular one. So this should have two tests that succeed, hopefully, if my code was running correctly, which it does, right? It's kind of cool. Now we can kind of test, well, we can test how this works, or we can test a failure. So if I go back to my math services, we know that this succeeded, right? That's, we got all green. But I'm going to change add to subtract, like we were talking about, and do the .NET test, and you're going to see some red. It looks like a build error, but it's not a build error because this is still going to build. If I go back to this directory, it's going to build. There's not going to be an error, but it didn't pass our test. And if you read in here, it'll tell you what happened. So it says, here's the function that specifically failed and the difference that actually happened, right? Expected 15, actuals -5, right? Here's the stack trace, and there's an error. So it said test summary total 2, failed 1, which is the one that we failed, succeeded 1, skipped whatever. So again, think about being in a big team when you're programming and you wrote some awesome algorithm and someone screwed it up. This will tell you, the unit test will tell you, because it's always going to check what you think is going to return 15, 20, 50, whatever. So at the very minimum, this error will tell us what's wrong, right? So I know that this error, or there's an error in add should return correct sum. So I would go to the test, check out, which service or file that is wrong, which hopefully is right, or it is right here, right? Because math service.add is actually returning the wrong result. Sorry about that. And with that, we can determine where the problem in the code is. So we can go back to service, change it back to plus, and then we're good to go. Do the test again. There's thousands of these tests. In fact, there are specific unit test developers out there. They make a lot of money if you're good at them. Writing the test cases, pretty popular. A lot of lazy quote unquote developers. That happens to all of us. We'll write the unit test after they write the function, whereas typically you're supposed to write the unit test before you write the function, because then you can, hit the expected output. So that's it. I know we're just at 30 minutes. As a reminder, we looked at um, dependency injection, right? So if you look at the home controller, we instantiate with a service that we need, DB context, in this case logger, and the math service that we created. We looked at decoupling our code. Next week, we're going to go deeper into decoupling, and hopefully you see that we needed to decouple this so that we could use the unit test, and obviously we checked out the unit test. For assignment 3, you should get started now. You only have until December 2nd to do it, but you could actually start the unit tests with, at the bare minimum, um, the stoic part of that. I think it's part 2. And also setting up your unit tests. I'm not going to post this code because you can get it, or you can at least walk through getting this code on eConestoga. I'm pretty sure if you copy and paste this, it should be okay, or it should work. Just watch out for that add reference because I kind of added it after. And that's it.